Hello students, in this video we are going to discuss about the text exercise question 4th and 5 that is based on the concept of ozonolysis of alkene. So first we will be discussing the question number 4. Write the IUPAC name of the product obtained by the ozonolysis of the following compound. So here we have to do the ozonolysis of following alkenes and we have to find out the product and we have to write the IUPAC name of the product which is obtained during the ozonolysis of the following compound. So first of all we'll try the first one, that is pent-2-ene. So in order to do the ozonolysis, first you need to make the structure for pent-2-ene. So this is what actually it is given here, pent-2-ene. Pent means the number of carbon, that is the word root. Pent means 5 carbon. So make the 5 carbon like this. And what it is given, pent-2-ene. So we'll start the counting from here. 1, this is 2, this is 3, 4, 5. And on the second carbon there is a double bond. So keep the double bond here and rest of the bond you have to keep single. And keep the number of hydrogen on the basis of the valency of each. That is, it should be tetravalent. So here it will be how many number of hydrogen? Here will be 3. This one 1 here, and here 1 hydrogen. 2 hydrogens. So this is what the structure for pent-2-ene. Now what we need to do here for doing the ozonolysis, we have to select the focusing area. Which is the focusing area here? That is the double bonded carbon. We have to focus on the double bonded carbon. That is, these two are the double bonded carbon. So with the reaction with ozone, there is a formation of ozonide, and I told you how to make ozonide. And the double bond between the two carbon, that you have to rub it. So better will be rub it, this double bond between the two carbon. So this is what actually called as ozonoid. Ozonoid, it's a cyclic compound, you can see, when the alkene combines with ozone to form ozonide. Now what is the next step? In the next step we have to cleave this bond in this way. That is, we have to cleave this here in this way. So when you cleave this one will be the one product and this one will be the other product. So in order to make that product, so how you make this one? Now rub it out this one, because this O will get removed as a side product and this bond get cleaved, that is between the two oxygen, this bond get cleaved. And now what is there here? There is a formation of double bond between the carbon and oxygen. So keep a double bond here, that is the double bond between this carbon and oxygen, a double bond is formed. So here also a double bond is formed. So this is what the two product which is formed during the ozonolysis of pent-2-ene. Now how we name this one? Look at here, this one is CH3 CH double bond O, that is CH3 CHO. That is what an aldehyde, because CHO group is an aldehyde group. And which aldehyde this is? 2 carbon aldehyde, that is ethanol. So what is the name for this one? Ethanol. And look at the next one, that is this one. This compound, this is CH3 CH2 and CH double bond O means that is CH3 CH2 CHO, that is an aldehyde group. So what is the name for this one? This is 1, 2, 3 carbon aldehyde, that is propanol. So we have come up with the product and also we have we have written the IUPAC name. That is the two structures which is formed here. That is what it is given here. That is propanol and ethanol are the two product which is formed during the ozonolysis of pent-2-ene. But in simple words, how without being the second step, how we can come up with the product, that I will going to explain here. So better I will write once again, that is CH3 pent-2-ene. I will write once again CH3 CH2 CH double bond CH CH3. So what I'll be going to do here, just how I can make the product very easily without an intermediate step that you have to learn. So better write the formula for the alkene which is given to us, that is pent-2-ene. So this is the formula for pent-2-ene, that is 1 2 3 carbon, 4 5 carbon, and the double bond is between the second and third carbon. So first you rub the double bond between the two carbon, and then what you need to do here, you have to keep double bond O here, keep double bond O here on the same carbon which was bonded by double bond. So on that carbon one double bond O when you get added, so this one is the one product and this one is the other product, that is this is CH3 CH2 CHO and this is CH3 CHO. So this is in simple words you can make the product very easily. Now the next example will be going to write in the same manner, that is the next one is 3,4 dimethyl pent-2-ene. 3,4 dimethyl hept-3-ene. So we'll be making the structure. So this is what the structure it is for 3,4 dimethyl hept-3-ene. Now how I told you, you have to make the product very easily. First of all, remove the double bond between the two carbon. First you remove the double bonded between the two carbon, and on that carbon keep double bond O, on the next carbon also double bonded O. So this one will be the one product and the other one will be this product. So that is what actually it is given here. So what is the structure it is formed? The name of this one is pent-2-one and this one is butane-2-one. So the ketones are formed from this way. So next one will be doing in the same manner, that is the next one is 2-ethyl but-1-ene. First of all, it is very necessary to make the structure properly. So what is the structure? That is 2-ethyl but-1-ene. This is the structure which is given here. So how you make the product? Easily, just remove the double bond between the two carbon, and on this carbon keep double bond O, on the other carbon also double bond O. So this one will be the one product. So you can write that product as it is, and this one will be the other product. So that is this is actually only carbon with CH2 double bond O means what is this one? This is HCHO, that is the aldehyde, simplest aldehyde, that is methanol, because one carbon aldehyde, therefore methanol, or the common name is formaldehyde. The next one will be doing in the same manner, that is 1-phenyl but-1-ene. So better will make the structure here butene. So start with the word root but, 1 2 3 4 but. 1-ene means between the first and second carbon there is a double bond. 1-phenyl means on the first carbon there is a phenyl group, that is we can make the benzene ring here, or we can write C6H5. Now keep the rest of the carbon-carbon bond as single and write the correct number of hydrogen by checking the valency of each carbon. So on this first carbon, now you can check here 1 2 3. 3 bond is already there, that you can check here. 3 bond is already there. So better I will make that 3 1 2 3. 3 bond is already there. So how much bond hydrogen should be there? A single hydrogen. Now look at the second carbon. On the second carbon 1 2 3 bond is already there. So 1 hydrogen should be here. Next on the third carbon 1 bond 2 bond. 2 bond is already there. So 2 hydrogen here, and here 3 hydrogen. So it is very important that after keeping the double bond and single bond, check the valency of each carbon. It should be 4. So on the basis of that you can add hydrogen. So here this is a 4 carbon alkene which is given to us. Now we have to do the ozonolysis. So how easily we can make the product? I told you, rub the double bond between the two carbon of alkene, and then you have to keep double bond on this carbon, that is doubly bonded carbon. You have to keep double bond O, and in this also keep a double bonded O. So this one is one product and this one is the other product. So what is this first product? First product is C6H5CHO. First product is C6H5CHO. That is what actually is benzaldehyde. C6H5CHO is a benzaldehyde, and this one, that is the second one, 1, 2, 3 carbon aldehyde, that is propanol. That is propanol. Al is the suffix used for aldehyde, therefore it is propanol. So in this way we have to come up with the product very easily. We just wrap the double bond and keep a double bond O between that, keep the double bond O for that carbon which was doubly bonded. So in this way you can find out the product very easily. So here the next question is question number 5th. An alkene A on ozonolysis gives a mixture of ethanol and pentane 3-one. Write the structure of and IUP is the name of A. So what is actually, we can make a rough ray diagram here. What is given to us? An alkene, and we will be representing, that is A, because it is represented in the question also. A is an alkene. It is an alkene which is on ozonolysis. It is giving rise to two products, that is ethanol and pentane 3-one. That is the two product which is found here. It is ethanol and pent 3-one. That is what it is given in the question. So the product is known to us, but we are unknown of the alkene A. So we have to find out the alkene A that is undergoing ozonolysis to give the product, that is ethanol and pentane 3-one. So here the products are known to us, but we don't know the reactant. So that we have to find it out. So how we find it out, this one? So first you have to make the structure for the product, that is ethanol and pentane 3-one. Make the structure for this one. So when we make the structure here, that is ethanol and pentane 3-one, you make the structure as it is given here, structure. Now how we find out the alkene? So I will rearrange the structure in this way. Ethanol, that is CH3, CHO. I can write a CH double bond O. This I am writing here. The next one is pentane 3-one. So this structure I will just rearrange and I will write in this way. That is C. Here it is double bond O. CH2, CH3. Then this one is CH2, CH3. So I have just to rearrange, and I am writing the double bonded O down so that I can come with the product I can come with the alkene very easily. So this is what actually the two products are formed. Now how we come up with the alkene? We know that there is a double bond between the two carbon on which now there is a double bonded oxygen. So what we'll be going to do? We'll be rubbing this double bonded O. So we'll rub this double bonded O, and what is formed? There will be double bond between these two carbons. So that we have to keep now. Now here there is a double bond where that is the double bond is between these two. So this is what the alkene which is on ozonolysis is giving rise to these two products. So here in this video we have discussed the two questions on ozonolysis. In the first question, what is in the first question, reactant is known to us. That is, reactant is known, but we don't know the product. But in this case, product is known to us, but we don't know the reactant. So follow the method which I used here to make the product very easily and to come up with the reactant very easily. So for all these you need to make the structure properly, then only you can able to come with the right product. So this is all about this video. Have a nice day.